Okay, so you're questioning me about question number 2.
Yeah.
So read it out for me while I clean the board.
X is on the x plane as the vector, and then you've got y which is the 45 degrees plane. And it says which vector diagram represents R, vector x minus vector y.
Okay, so question 2, you've got 2 vectors. You want to know which one represents vector x minus y. So vector x is the vector that goes like that. Y goes like that. So it's from, pointing from bottom left to top right in a diagonal, about 45 degrees. When you have a minus vector, so minus y, it's the same magnitude, but it's the opposite direction. So what you do is you turn it around, and it will look like that. So when you put the vectors together, x will go like that. It will go from left to right horizontally. Then y, because it's minus, will go from top right to bottom left diagonally. And then the resultant that you get is from where x starts to where y ends. So the resultant will be down that way, which is why you're going to end up with, let's have a look. Y looks like D. D. Yep, Marnie. Okay, so they're asking you to 2 vectors x and y, which vector represents R, which is vector x plus y. So x is, and I'm actually being very specific as I put it on tape. That's why I'm talking like this a bit. But x is the one that goes left to right horizontally, and then y goes bottom left to top right 45 degrees. So it goes like that. To add them together, you draw x, and then you go from the end of x, you draw y, and your resultant is from where x starts, it goes all the way to the end of y. It will look like that.
So that wasn't the answer then?
Yeah, it was, yeah.
It's just flipped over.
It was C. Yeah.
Which will be C. Yeah. Now, the thing is, you said it's flipped over. If I put 2 plus 4, what does that equal?
6.
6. What does 4 plus 2 equal?
6.
6. So does it matter which order I put them in? No. And vectors are exactly the same. That's, in mathematics, called being commutative. It means it doesn't matter the order that you put things in. Now, you know that there are times when it is going to be important, isn't it? That there are some operations in maths that you can't just reverse round. It doesn't make any difference. But, some things commutate and some things don't. Okay? And it's the same with vectors. No, it's commutate is the word. Yeah.
Question 4.
Question 4.
So it says the acceleration is constant throughout the path.
That's right.
How can it be constant?
Okay. Remember when I talked about the danger of scalar thinking versus vector thinking?
Yeah.
Right. So here's an object that a ball, say, is thrown. It goes up in a loop and it comes down again. At some point, it's going to v equals 0. At some point, it had an upwards velocity, positive, and at some points, it had a velocity going that way, right? So clearly, this thing's accelerating because you've got a change in velocity or a change in speed. Now, if you're talking about scalar modelling of it, change in speed, you start off with a speed that way, at some magnitude, and it's slowing down. So in your view, from your point of view, you're saying up here the acceleration becomes zero, and then the acceleration gets greater and greater, right? But, well, that's a scalar view of acceleration. When you have a ball, once it's left the cannon or whatever fires it, what's the only force acting on it? Gravity. Now at this point, the force of gravity is a certain amount. When it gets there, what can you tell me about the force of gravity? It's exactly the same, isn't it? The force on there is exactly the same, and at the end of its journey, the force of gravity is still exactly the same. The mass of the ball doesn't change. So what can you tell me about the acceleration at that point, and that point? It's the same. And it's constantly downwards at a figure that we say is 9.8, which is almost right.
But there's also the thing that shoots it out. That gives it the
When you do this stuff, right, when I take this, I get it from 0, and I throw it, and I'm actually going to throw it. When I take this splash and throw it, it starts at 0, and it will have some speed when it leaves my hand, right? Once it's left my hand, is there anything else pushing on it? There's no force. So once it leaves my hand, there is no force being applied to it. So the only thing that's applying to it is gravity. That's why it does that curvy thing.
But why does it continue to go up if it's only gravity?
Well, it already has a velocity.
Yeah.
Okay, and it takes a while for that force to slow it down. I can do it straight up and down. It takes a little while to slow down, and then it'll be accelerated down again.
Yeah.
But the gravity, from the moment it leaves my hand, gravity is the force acting on it, slowing it down and then accelerating it back. Does that make sense?
Yeah, when the magnitude of the object's velocity is greatest at which
Right.
phase thing?
Where? Which question is that one?
That's the same question, that's what it's asking.
I thought it was the acceleration is question 4.
Yeah, it is.
Okay.
Question 3.
Question 3. Now, the way they've drawn that diagram is a bit tricky. Okay? So they're not mentioning the direction of it, where you have a plus and a minus. They're just asking the magnitude. So saying which has the greatest size speed. Now, up at B, at the very top of the arc, what will its speed be? 0. As it goes down, so it looks like about a third of the way down at C, it will be accelerated to some amount, but it's only a third of the way down, so it's not going to be that quick. If you look at D, it's getting faster, but it's not quite at the end of its journey, is it? A is right at the start of its journey. It's only just left whatever's thrown it.
Yeah, but how do you know that you don't know how much force is being put on it so that...
But what I do know, if something has a force applied to it through the same distance, so if it started at 40 kilometres an hour out of my hand, it'll go a certain height, it will come to 0. If it comes to the same level as my hand again, because it's been accelerated by exactly the same amount, so it'll take exactly the same time to get halfway, exactly the same time to get back down again, what can you tell me about the speed when it reaches that level? It'll be the same. So they've drawn this diagram very carefully. So D is just a little bit higher in its journey than A, which means that D is not where it has its greatest magnitude of velocity. So the answer is A.
So it goes up and then it comes back down and accelerates at 9.8 meters per second down.
Per second, yeah.
And if D was at the same level as A, it would have to be A.
So if I threw something out of my hand with a velocity of 9.8 metres per second,
Yeah.
it'll take 1 second for it to stop going up, won't it? Because it's being accelerated that way at 9.8 metres per second. Then it'll come back down, it'll fall for 1 second to come back to my hand. So it must, because it accelerates for 1 second, when it hits my hand again, it will be 9.8 metres per second. So the speed it leaves my hand with, as long as it comes back to the same level, will be the speed it hits my hand at.
Yeah.
Okay?
So it won't lose any energy from this joke. I'll lose energy.
It doesn't, the energy here starts off kinetic, ends up being totally stored as potential, and then ends up as kinetic again. But that's main idea 3.
Yeah.
Yeah. Yeah. Any other problems people wanted me to go through? Yeah.
Question 8.
8. The following diagram represents the successive frames of film taken of an object thrown in the air. Okay, that's easy enough. Using this information, the position of the object in the 4th frame is. Okay, so what they're sorry?
What was the answer for that question? Yeah, I don't understand how it works.
Okay, so it's a matter of elimination from the ones that you go through. Now, so its speed has decreased. It looks like a distance grid, doesn't it, on the side?
Yeah.
So it's gone up by 2, it's come down by 2. In that case,
Next one is supposed to be all right.
yeah. Well, there is a formula I could use to work that one out that you guys don't have yet. So that makes that question a bit of a guesswork for you, really. But one, you can eliminate C straight away.
Yeah, because the same frame. Yeah.
And also, what can you tell about looking at the horizontal distance on it?
Most of the distance.
Yeah, look at the bottom. Look at the x-axis.
So the same, if it's the same as where it was up there, so it can't be the same two ways at the same time.
That's right. So it can't be C. It's not going to be A. Why won't it be A?
Plus I thought it was.
All right. It obviously can't be A because when you look at frame 2, it is at vertically it's at 8. In frame 3, it's vertically at 6. It's fallen 2, right? It would have to at least double on the way back down. It might be more. So it can't be
Well, I'd have to at least double what
because it's accelerating.
Oh,
Okay? Because it's accelerating down, it cannot just be another 2 units down. It has to be more than that. And it will actually be doubled. The relationship is time doubled. Actually time squared it is.
So it's time distance.
Yeah, the amount it travels is related to the time. So A and C are out of the frame. It can't be either of those. And then you're left with not quite enough information to choose between B and D. But D is the answer in that one. Okay, any others? No? Everyone's good with those? Good. If you didn't finish them all, do them tonight, have a go at them, and then we can go back. Can I do what? 11. I can do 11. I hope I can get it right. Yeah, that one's a bit more tricky. Yeah. An object is undergoing circular motion at point X. Its instantaneous velocity is v1. At point Y, its instantaneous velocity is v2. And the reason for that's simple. If I have a ball on a string and I'm swinging it around my head, it'll go in a circle, right? But the minute I let go of that string, what will it do? It's going in a straight line. So they're just instantaneous velocity is a vector which represents how fast it will go in that straight line. And that's what's shown there. And what do you notice about the length of those two vectors? They're the same. They have to be the same or you wouldn't be going in a circle. Okay? And it's asking you to work out the change in velocity. Now, change in velocity